Okay, so back to the remove. All we did was copy over the contents of the last person and replace the one we want to remove with the reference to the thing in size -1, which is the last one. Then we need to say, okay, thing at size -1, you reference null now. Null is like none. It's a special value that means like nothing. So you now point to null. And then we decrease size by 1 because we just eliminated something from that collection. So now there's one less thing in it. You will notice, however, by doing this, the order of individuals used to be like this was 1, this was 2, this was 3, this was 4. But after it's done, this is gone and this becomes 2. So the person that was at the end has now kind of like jumped over to be in the middle. But that's fine because we have, this collection has no ordering to it. There's no, the order of these people doesn't matter to us. So it doesn't matter that we are messing up the order. And the awesome thing about this is, and I know we talked about this last time, but just to refresh, if I have a big long array that is size a billion, 1 0 0 0 0 0 0 0 0 0, size a billion, and I want to delete this one. If I deleted this one and I wanted to make it go bad, like go away, I would have to copy the thing at index 1 and put it in index 0, then the thing at index 2 and put it in index 1, and then the thing at index 3 and put it in index 2, and then the 4, 3, and so on and so on and so on. And if I did that for all a million -1 things, that's a lot of work, right? How many things am I moving? A billion -1. I said a million. I meant a billion -1. That's a lot. Where, if I took the other strategy of just saying, the thing at the end, you're now null, and then copy over, and then have this be, like we put this here and then set this to null. So we are either moving a billion -1 things or 2. What's better? Obviously it's the 2. So this is awesome. A huge benefit, right? Because now we have something that would take linear time, where the amount of work required is proportional to like the length of the thing, n, to now it's constant time, where the size of the array really doesn't have any impact on how long it takes to remove. So if you can have a function or a method go from linear to constant time, do it. That's awesome. Can you just bubble sort if you need order to remedy this? We're going to talk. So you raise a very good question. We are going to talk about ways of addressing this if sorting matters. But if you did that with bubble sort, you would end up having to bubble it all the way back up to the top. If the order, like if the thing at the end was in there, you'd move it and you have to bubble it all. It'd still be linear time. But we'll talk about that more later, because there's a couple of interesting ways about going to address that. Good question though, very good question. All right, to remove friend, we all need to do is lose reference to it, garbage. So this is the idea that if you ever have a reference to an object, if I have some, I don't know, friend object, and we have a reference to it through this variable over here, and we have a reference to it through this variable over here, so now we have an alias. We have 2 aliases for the same one object here. If I come along and say, okay, A over here, this one, you don't point there anymore. You're going to point over to, I don't know, something else. It's off screen, doesn't matter. At this point, now we don't have an alias anymore because A doesn't reference this guy. It references something else. But over here, if we have B, this is B. B is still referencing it, so we're fine. You know, we still have reference to it. We can access this friend object. But as soon as I say something like, okay, B, you equal something else, I don't know, it goes off here to the edge of the, and to point to something else. So this doesn't exist anymore. Now, this object is existing in our computer in RAM, but nothing references it, meaning we can't get to it anymore. I have no way of accessing this object anymore. Before, when I had a reference to it, I could be like, okay, B, tell me your name. Now I have no way of asking that object what its name is. So this means it is effectively useless. It's effectively gone. We can't do anything with it. So this takes up space in our computer. Fortunately, Java has this system called garbage collection, Python does too, where if something is ever existing in your RAM, but is not referenced by anything in your program, it'll come along and go like, okay, well, we can free up this RAM. We don't need to have it saved anymore. This we can use for something else. So just a neat little point there. All right, garbage. Friend array at the sides, it's always friend -1. Hopefully friend count -1 makes sense to you, because if friend count is always the available next spot, friend -1 is the last not empty spot. Move this. Oh. Okay, after this, let's see, okay. Reference to friend, so it's null. Okay, you may also notice that this method, as its person, will not do anything special if friend we try to remove does not exist. What should we do? Yes, this is a good point. What if I say remove friend Bob, but there's no Bob? What should we do? Well, should we ignore it? Should we return a Boolean? Should we crash the program? Should our computer explode? I don't know. This will kind of depend on our circumstances and really what we want it to do. But this is something we will discuss a little bit later in the course. Just something, I like the do nothing. The ignore it is just, yeah, leave it alone. Just carry on as if nothing matters. Computer explodes sound cool. You can test that one out. All right. You just ignore it. I think I say that, but maybe I don't. Just check it. Update friend's email. Okay, here's one. Update friend's email. So here's the idea. Update friend email. It's going to take the string of the name, last name, and then a new email address. So you remember, in order to identify a friend object, we are going to look at friend, its equals. And its equals just basically compares the first names and the last names. It doesn't care about the email address. So I don't need the old email address to uniquely identify a friend. So, contact list. Update email. Why is this? All right. I don't know why this is like incomplete. Update email. Okay, that's nowhere near correct. So I'm just gonna fill this in as we go. So we need the first name and the last name of the friend we want to update their email address of. And then the new email address. So in this example here, I did that like dummy friend thing again, where I create a new friend object that only exists for the purpose of comparing friend objects. Because, and again, you'll notice that the email, I just left it as a blank string because it's not important. I could have made this Jimmy Bob 42. It doesn't matter because it has no impact on checking equality of friends. So this is our dummy thing to go look for our friend. And then here, it's just a linear search. Start at 0, go to the friends count. And then if the thing we want to update is equivalent to the current friend I'm looking at, well, the current friend I'm looking at, set your email to the new email address. And you better remember that we have a set email method here. So yeah, we could do that. Easy peasy. I'm going to do this slightly differently, where I'm not going to make use of the equals method, of the dot equals of the friend at least. What I'm going to do is just start my linear search and then say, okay, if friends at index i's first name is equal to the first name, and, oh, nope. There we go. And friends at index I dot get last name dot equals last name. And I'm going to do this so it just formats a little nicer so we can see it all on one thing. So if the first and last names match, if the first and last name of the current friend I'm looking at match what I'm looking for as defined by here, then I know I have found the friend I want to update their email for. This right here is making it so I just don't need the dummy variable. If you like to use the dummy variable, great. If not, whatever. For here, it's not going to matter too much. But if you go look at your friends equals, you'll see, like, we're just asking if the first names are equal and the last names are equal. It's effectively identical to what this is. I just wrote it here. And what's this saying? If. Okay. So if we find them, all I have to do is say, okay, well then, now I know that friends at index I is the one I'm looking for. So friends at index I, set email to be the new email. Great. So here we're doing a linear search. As soon as we find the friend, we just update their email. If the way this is written, if it just so happens that we have two friends in our contact list with the same first and last name, it'll go through and update all their emails, which may be what you want, maybe not. It'll depend on what you need it to do, but for our purposes here, it's fine. And then you'll notice that if we ever get through this loop and we never find it, nothing changes, which is what we want. If we want to say update email of some friend that doesn't exist, it shouldn't do anything. Okay, so there's update email. Okay, index of is a great one. I understand that equals checks if two friends are the same, but here, how is it checking the names are the same? Because dot equals is defined for every object. So this right here is the strings dot equal. When I check if dot equals on what this is, and this right here it's a string. It's the first name of this object. So I'm asking if this string equals that string. Oh, that makes sense. Okay, cool. And for Jamie, it's right here. That's it was passed as a parameter to the method. So I didn't just make it up. It existed as defined in the parameter list. Okay, index of. So this is a good one. Index of is going to be a simple little method that you might even want to make use of in your assignment 1. You don't have to, but you totally could. Public int of string first name, string last name. Okay? And the point of this method is to just tell me which index in my friends list does a given friend exist, if they exist in there, right? So it's basically going to be exactly this method right here, this update email. Except instead of making any change, all I'm going to do is just return whatever I is. So here, I'm going to do this, copy, paste. Instead of this, just return I. So what am I doing? For int I equals 0, I is less than size, I plus plus. If friends at the current index, his first name is equal to the first name that we passed it, and friend at index I's last name is equal to the last name we gave it, we know we found it. We know it's at friends at index I, so return index I. Great. But if I ever get to the end and I don't find it, I'll just return -1. Because that'll signify to us that, okay, it's not in there. Because this needs to return an integer. So what value might be useful? Well, there's no negative indices, so -1 would be very clear to me that I didn't find it. And we call this right here a sentinel value. This is not something you need to, like, this is not on the exam. The word sentinel value, if you forget it, it's fine. But basically it's a value that's returned that's clearly not the answer to the question, but it has other special meaning here. So here, the -1, we're using that to mean it doesn't exist. Again, in this example here, I used that dummy friend example. Could totally go about doing that. But here, I just left it like this because. Now, what's kind of neat here is you might say, well, hold on. I'm kind of like repeating myself. So what I can do, in fact, remove, update email. Oh yeah, here, I was just actually saying that. I could just remove all of this here because index of tells me the index of the friend. So I can say int to update our index equals index of first name, last name. So now I'm going to call this method, inside this method, update email. First I'm going to say, okay, update email, go and find the index of this friend. If index is not equal to -1, then I will do that. Oops, not friend, index. This is pretty cool. So now I can make use of index of in this method. So I don't need to repeat this whole linear search code. There's nothing wrong with repeating it. That's not bad, but this will totally work here as well. I just do the index of. However, there is one critical piece of functionality of our update email that has changed as a consequence of doing this. Can anyone tell me what it is? This is a tough question, so if you don't know the answer, you're normal. But I'm curious if anyone knows what it is. I'll give you a second. Oh, and of course, similarly here, where I'm doing remove. See how here with remove, we're using the dummy one, but we're doing a linear search here. We could replace all of this stuff here with the index of. We could just call index of, find the one we want to remove, and if index of, or if index is not -1, you do this stuff. Pretty cool. So this is a nice way of like having a method that just helps us solve our other problems. You know, it's great. But the error. What error? Well, no, that's why you say if index is not equal to -1, then you do it. Otherwise, you just ignore it because it wasn't found. All right, so to answer the question I was asking before, in this particular example, when I call index of and I'm looking for something, as soon as it finds a matching friend, it returns the index. So if I have a friend at index 6, this returns 6, this isn't there, and I set friends value to the friend at index 6 is I update their email. And then I'm done. Great, awesome. But before, it actually searched through the whole thing. Meaning if you had multiple friends with the same first and last name, it would have updated all of their email addresses. Where this now, the way it's written, it'll only update the first occurrence of it. So if you're asking yourself now, well, what's correct? That's not an answerable question at this point. It's, well, do you want it to update all of them or not? If you do want it to update them all, well, then this is not very good. If you really only want it to update the first instance, well, this is great. So you got to be careful here. And this actually came up in lab yesterday, which is funny. Same thing with remove here. Remove is actually trouble. Actually, this remove is trouble, isn't it? Friend is that. Yeah, ooh, this remove is trouble. I need to fix this. When would you only want the first instance? Whenever you do. It's actually a very common thing to do. Only remove the first occurrence of. And then, if you want to remove them all, you could like ask, does this exist? Remove Does it exist? Remove. Does it exist? Remove. So you just end up asking it to remove however many times that thing is in there. It gives you more flexibility. Where if you remove them all, you can remove them all. If you only remove one, well, you remove one, and then if you want to remove them all, you just keep calling remove until they're all gone. So you get a little bit more functionality. This remove is wrong. This needs to get fixed. This actually has a big bug in here because it'll try to remove all the friends, but really it should, pardon me, here. Not this remove. This remove is trouble. This remove, we have a problem because it's going to try to remove all the friends. But this can create an issue where, and this was talked about in yesterday's lab, but not on Friday's lab, but this can create an issue. I hear a boop. Yeah, so that's, I'm not sure what you mean, but just listen here anyways, so. Let's say I have smiley face, sad, angry person, winking person, I don't know, and then another smiley face, meaning this one and this one are the same. Whoops. In this remove right here, we've got a bug. And this is actually a very difficult to find logic bug. So if let's say for example, I come along and say, oh, the thing at index 0. The thing at index 0, right? I0, oh, friends at index 0 is equal to the dummy. This is the one I want to remove. So I go along and run this code. Okay, so I basically, this now points here. Where's my thing? This isn't there anymore. It points to null. And yeah, this is gone. Great. So we've effectively put the equivalent person, the smiley face person, into index 0. But the problem is, we now finished that. We finished the if statement. We go here, I becomes 1. I is now 1, and we check. Oh, is angry, no, it's not the person I'm looking for, not the person I'm looking for, and then we're done because this doesn't exist anymore, right? It's null. But the problem is, I didn't delete all occurrences. I actually just deleted one, and then put effectively an identical one in its old spot, and then we just kind of like skipped over it. And this is not a case of, well, you're still only deleting the first occurrence. Well, no, because if this person here, imagine this person here, ooh, where's my cursor? I'll just use my mouse, if I can see it. If this person here was a smiley face, let's change him to a smiley. Trust me, that's a smiley face. If we change him to a smiley, we'd remove him. Okay, he'd be cut. He's gone. So we'd have removed 2 of the smiley faces, but index 0 still references this smiley face. So we actually left some of them in there, which is a big problem. So this actually has a bug. And do I actually mention the bug in the course notes at all, or did that one sneak past me? I want to check. Because if it snuck past me, we got a problem. Java, okay, remove friends. Above example, reference at the end, after this array, you may have noticed the index is null. Okay, this is discussed further. Okay, cool. It doesn't say anything there. Index of. Warning. The above change actually alters the functionality of remove and update method. Try to figure out what changed. Is this a good change or bad change? Hey, what happens if there are multiple friends with the same first name, last name? Okay, I kind of talk about it, but you know what? I could probably improve this hint a little bit. Anyways, carrying on. Remove, great. Update email, great. With this new improvement here, it'll only find the first one. It gets the index of the first occurring one based on this, because as soon as we find it, we return it. And then we go and we make the change to only one of them. Did that make sense? How can you do all? That's an exercise for the students. It's easy to do. You could just call. You could do it that way, or the easier thing is just write a method that, like, if you want remove, you could do remove all. Something like this. Public void all. You give it that. I would write probably another method, assume this exists, called like get count. Int number of equals get count. Give it first name. So imagine this method exists and it just counts the occurrences of a given first name and last name in there. Then I just say like for int equals 0, I is less than number of I plus plus, remove first name, last name. There, that's how I do it. Well, all I said was, so this part here is like, well, how would you do a remove all if you really wanted to remove all? Well, I would just make another method that would get the count of the objects that are equivalent and then loop that many times and do that many removes. That's all. No, index of solves the bug. But there are a billion, there's literally an infinite number of ways to go about solving the bug. With how things replace, you have more than one of the last instance. What? With how things replace, you'll have more than one of the last instance. I'm not sure what you mean. Okay. All right, let's move on. Okay, get. All right, this just returns the friend. And here, it's easy. We'll write two gets. We'll write a one that's, okay, public friend. So this will return the friend at a given index. Get int index. And then I could do a little bit of bounds checking here. Or not. It could just return it can just crash. But I can do like return friends at index. This is totally workable. In the example I gave here, I say if the index is less than 0, or pardon me, if the index is greater than -1 and less than friends count, meaning it's a valid index, return the friend. Otherwise, return null. Yeah, that's probably maybe a better implementation, but I'm lazy, so right here I'm just going to do this. So if someone enters a -1, we'll just have like it crash, but in the same way that it would crash if you tried to index a negative value of any array. So now I'm going to write an overloaded friend. Public friend get. Or pardon me, an overloaded get, meaning I am writing two methods called get, but they're different. And you might say, well, hold on, you can't have two things with the same name. You can, as long as that they're like formal definitions are different. There. What I'll do now is if I call get with an index, I'll return the friend at that index. If I call get with a first name and a last name, I will have to go and find the index of that friend and then return the friend at that index. But I've actually done it in a really fancy way here. So here's what I can do. Let me show you what I mean. Int equals index of first name, last name. Then return, nope, at friend index. So effectively what this is doing is the same as get. It's just first I actually need to find the one with the matching first and last name and then return it. But if I want to get fancy, here I could actually just do like I could just call this method. I could call the original get with friend index, which is kind of neat, right? So I can actually just hijack this method here, which is kind of cool. But of course, this might return -1. So, I might have a problem. Maybe it would be good to do something like if index is not equal to -1, return null otherwise. There. So this is a way to kind of catch if I do it this fancy way. Missing return statement. Oh, right, I gotta return it. No, I hit overwrite. Return. This usually throws people off the first time they see it, especially coming from Python. But yeah, you can have overloaded methods, meaning they have the same name, but as long as they have different parameter sets, we're okay. So if I ever come along over here and say a list dot get, no, not course list, I want friends list. Oh, contact list equals new contact list. Imagine there's a bunch in there. If I ever say clist dot get with an integer in there, well, it's just going to return the friend at index 8. But if I did something like this, it'll return the index of Bob Smith, or pardon me, it'll return a reference to Bob Smith. It's just that this get has that extra step of looking for Bob Smith first. So instead of being provided with it, we have to search for the index, then get the index, and then return the friend at that index. So that's what happens there. More than one way to do the same thing. Exactly. Why would you do that? There's a bunch of reasons. One might be, imagine add for a second. Imagine you had like an add, but you wrote an add that takes integers, but then you try to add floats together. Oh, well, we got a problem. So now we need to write an add for floats, right? Clear friends. Oh, this is an easy one. Clear friends. We want to, you know, I had a big falling out with all my friends. Public void clear friends. All I have to do is say size equals 0. And that would probably do the trick, but just for good measure, let's say friends equals a new friends array at friends.length of the same size it originally was. I guess I could do default capacity, whatever. So basically ignore all the stuff that used to exist and just make a new array and set size to 0 and we're in great shape. Clear friends. No need to actually go through and remove them all. This is just way easier. Because again, imagine you had 1 billion friends in your list. What sounds easier, going through and removing all 1 billion of them, or set size to 0, make a new array? Right? Excuse me. Clear friends. Now toString. Ah, friend count. Perfect. Oh, that's just the size. Okay, toString. I hear a boop. So would doing size, it wouldn't delete the old array. It would still exist, but if you ever went to add something, it would overwrite whatever was in the original index. So to say effectively, I would reword it to effectively pretend that it's deleting the whole array. That might be a better way of saying it, but based on what you're saying, I think what you are thinking is correct. It's kind of like saying, I have a big long array, right? And then, and if this is all full of references and whatnot, I should make those a different color. Just these lines, have them they represent references to objects, okay? And then if I ever wanted to add something, it would go to index size, right? Well, if we come along and say size is 0 and we ever want to add another thing again, we say, oh, index size, you now reference this other new thing, right? So we're like pretending it's empty, even though it's not. That's all. Clear friends. And then the last one I wanted to do was toString. Now this one is cool because this is where we now like, in the same way that we used equals in our equals. So if we go look at friend, and we look at equals, we are asking, well, the way this one's written, here, let me go look at the one on the course code, equals, up here. Equals, okay. So see how in the equals for friends, this is in the friend class, I'm saying, hey, first name, do you equal other's first name? This is calling the string's first name, right? So this is calling the strings equals. So in my equals, I'm making use of like another class's equals, which is cool. Now in my case, for toString, I can actually make use of the toString for my friends. So let me show you what I mean. Okay. And we're gonna do like string building here. Clear friends. Oh. Public string. Remember, our toStrings don't print anything, they return string. toString. Okay, great. So here's what I'm gonna do. Just follow, like, go with me on this and I'll explain it in a moment. Start with a string, S, and we'll start it as an empty string. Then we can always append to strings. So what I'm gonna do is say for int I equals 0, I is less than size, I plus plus. Okay, so now I'm gonna loop through each friend. I'm gonna say friends at index I, go to your string, stringify yourself. And then after, because that returns a string, right? If I click on this, it'll take me to my toString of that friend. So I'm calling the friend's toString, which is going to return the string of that friend's first name, last name, and email address. So I say friends at index I, give me your first name, last name, email address. Then index I will become +1, so 1. Friends at index I's first name, last name, email address. Now, for formatting purposes, I'll add a new line after each, and I want to take this and append it to the end of this string. So S equals S plus that. So it starts as an empty string, and then append to it, then make it equal to, well, take the empty string, append the string of friends at I, add a new line. Then take that string, append it, take that updated string, append it, and then at the end, return S. That's what's going on here. A neat little thing, if you care, plus equals actually works on strings as well. Yeah. So it'll like S equals S plus also works there, but just for readability, I'll leave it like that. And what's it saying here? Does it want me to do? Yeah. There is a better way to do this with String Builder. In fact, I think, look at that, it did it for me. But this is a little easier to understand in terms of what's happening, in my opinion. So this toString will turn the whole contact list into a big long string, based on the string versions of the friends in that contact list. I hear a boop. What's the difference between the toString method and the one you showed before? Well, this is the toString for the contact list. This is the toString for a friend. So if I ask a friend, hey, give me the string version of yourself, it returns the string of the first name, last name, email address. But if I ask the whole contact list, I want to get all the strings of all the friends. Formatted nicely, of course. Yeah, that's basically it, Anon, yeah. So then to test it, I've got my contact list. CList.add Bob. Here, actually, if I go down here, perfect. I'll just take all this right here. Okay, great. So now I've just added all these friends. Now, if I say s out, my friends, because again, my friends is a contact list, meaning I'm calling this toString, which in turn calls this toString, which is the friends. So the toString calls the other class's toString, which is pretty cool. So we've like cascaded the toStrings down. So again, contact list object. If I asked an individual friend to print out, it would only print out that individual friend's stuff. But now if I do this, we'll see eventually when it runs, Bob Smith, Jane Doe, Clarence Cartwright, Sandy Seaside, Adam Fluffson, and Adrian Andrews. All of them there, which is pretty cool. No, like how did you differentiate them while calling it? Because it depends on the context. My friends is a contact list, meaning it knows that it need like, that means it's calling the contact lists to friend. toString. Ugh, I'm getting tongue-tied. Here, because I'm calling the toString on friends at index I, and friends at index I is it's an individual friend, meaning when I say toString on that friend, it calls the friends toString. So it's context dependent, right? It'll depend on which object we're asking to string itself. Yeah. So if I say object flimflam toString, it's going to call the flimflams toString. If I'm calling bing bongs toString, it's going to call the bing bongs toString. Because it depends on, well, who are you asking? What's their class? What's their type? Cool. Any last questions? All right. In that case, I will see you all later. Enjoy the rest of your day.